Math 1314, section IC1, spring 2022, Tyler Junior College, section 3.3, complex numbers. Video 2, simplifying square roots of negative numbers. Now, if you're wondering why this is next in the video, recall where the number I came from. Remember that I, by definition, was the imaginary number that you square to get -1, but if you square root both sides, I is equal to the square root of -1. And remember that these two statements had verbal descriptions almost like they were commands that said, this is when you do something. And those commands went something like this. If you see, now I'm going to write an I squared in there, change it to, and I'm going to write a square root of -1 in there. Let me take this font size up one more notch. This is important enough to merit a larger font size. And again, I'm going to write some stuff in there. And the other one is if you see I can type that, change it to the square root of -1. Wait a minute. I can type -1 up here. So the two, for lack of a better word, instructions are if you see I squared, you change it to -1. And if you see I, you change it to the square root of -1, which makes things like I'm just going in circles. Why would I change? That last one is not what I want. And I'm so hoping in the previous video that I wrote it correctly. One second. Had a minor panic attack there. I just wanted to make sure in the previous video I did say the things I wanted to say. Here's the whiteboard from the previous video. If you see I squared, change it to -1. That is what I said. I also said if you see the square root of -1, change it to I. Here, I wrote if you see I, change it to the square root of -1, which is not a wrong thing to do, but is not what you would normally do. You would see a square root of -1 and you would change it to I. Oh boy, get that out of there. And you too. All right. So if you see a square root of -1, change it to I. And what that last thing does, what this does here, is it gives you the ability, I got a stray mark in there. Let me see if I can grab it. There we go. It gives you the ability to simplify square roots of negative numbers because it tells you what to do when you have a negative under there. So let's take a look at an example of simplifying a square root of a negative number. Simplify the following. The square root of -64 equals, the square root of -20 equals, and the square root of -15 equals. Now, when you see a negative under a square root, the first thing I would recommend doing is splitting it off of the rest of the number by writing the square root of -1 times the positive version of the number. -1 times 64 is -64, so this is a legitimate move. Now, why would I want to do that? Because we have a property of square roots that says if you have a product under a square root, and at least one of them is positive, in this case the 64, you can split it into a product of square roots. If you have a square root of a product, you can split it into the product of square roots. I meant to draw the first one in red. Not a problem. Just change the font color. Now, why would I want to do that? Why would I want to break off the -1 under its square root? Because I now have something to do with the square root of -1. According to this back here in the red box, if you see a square root of -1, change it to I see precisely that. So the square root of -1 becomes I. You know what? I'm going to do these on the next page because I want to go vertically here. So give me 1 second to grab and drop. Everybody down here, please. Okay, and this equal sign move down here. I guess I could just redraw that equal sign. But if you see a negative number under a square root, you can separate it from the rest of the number, put it in its own square root, and according to what we saw on the previous page, the square root of -1, when you see it, becomes an I. And we still have the square root of 64, but the square root of 64 is 8 because 8 squared is 64. So I've done the square root and I technically have an answer I times 8, but it would look better if I put it in standard form, which means to put the 8 in front of the I and say that my answer is 8I. So it really wasn't that difficult once we know how to deal with the square root of -1. I'm going to copy this, paste it to the next page. split off the negative 1 in its own square root. That becomes an I, and whatever the other square root does gets done. Now, let's do the square root of negative 20 like I had planned to do on that page as well, but I wanted to not crowd everything. All right, so we're going to take the square root of negative 20. What should we do first? Well, the first thing we should do is separate the negative from the rest of the number. Now, you can do this in one move or two. If you do it in two moves, then you want to literally break off the negative 1 from the rest of the number first, so that you may split this into two square roots. The square root of 20 preceded by the square root of negative 1. But let's be honest, this move is fairly predictable. So there's no reason why I can't just go from the problem to this line without having to pause and say, well, negative 1 times 20 under the square root and then split it. So in practice, it's probably a good idea to go from the square root directly to here without the small step in between. We could have done it back here as well. We could have gone directly from the square root of negative 64 to the square root of negative 1 times the square root of 64. We'll do that in the next example. All right, so what happens? Well, I know what happens to the negative square root of negative 1. It becomes an I. But what about the square root of 20? It's not like the square root of 64 where it has a clean answer. When you see a square root that you can't do completely, you're going to be expected to do it partially, if possible. In other words, to take the square root of 20, let's go back in black, please. To take the square root of 20 and rewrite it as two square roots multiplied times each other so that you can square root one of them. Well, there's a lot of ways to split 20. There's 1 times 20, except that's not splitting the 20. There's 2 times 10. There's 4 times 5. So which one should we use? Well, in this case, we're going to use 4 times 5. Why? Because when you're simplifying a square root, what you're really doing is trying to break off a piece in a multiplication problem whose square root you can answer. I know the square root of 4. The square root of 4 is 2. So off to the side over here, we're taking the square root of 20 to the side, breaking off the square root of 4, doing the square root of 4 to get just 2. Don't know the square root of 5, so I'm stuck with it. And let's see if I can get some better looking parentheses there. Okay, so the square root of 20 will simplify into 2 times the square root of 5. Putting that back into our flow over here, you know what? I really want something separating some stuff. So let's do this. There we go. And I don't even need those awkward yellow parentheses. All right. So back to the task at hand. The square root of 20 simplifies to 2 times the square root of 5. And at this point, we are at I times 2 times the square root of 5, which is not wrong, but it could look cleaner. Now, normally when we have an imaginary number, a number with an I attached to it, we would just stick it at the very end. And we could write 2 times the square root of 5i, which is not wrong. However, it's considered a little bit tricky to put an I after a square root, because if you accidentally put it under the square root, it is now technically wrong. So the one exception for sticking an I at the end of an imaginary number is when that imaginary number involves a square root that can't be finished, in which case it's always advisable to put the I immediately in front of that square root. So the best looking answer is actually 2i times the square root of 5, because we still have the I as close to the end as possible without accidentally sliding it under the square root. Let's see if I can, I'm just going to move that up, but I don't care. Okay, let's take a look at that last one, which is the square root of negative 15. It should still be there. Okay. Black, please. Thank you. Again, when you see a square root of a negative, your first move should be to separate the negative 1 into its own square root and leave the rest of the number behind as a positive. Now, if you do this enough, you're going to start realizing that the next move is always predictable. The square root of negative 1 by definition becomes an I. And then we have the square root of 15. So if you're looking to streamline the process, when you see a square root of a negative, you can instantly just take the negative out and throw an I in front. I could have done that back here. Well, I did two things here. I could, if that were still a square root of 20, and I could do the same thing over here. Well, again, I did both square roots at the same time. So maybe I didn't really illustrate it well back there. But my point is, when you're doing a square root of a negative, you can instantly do the square root of the negative 1 by itself and stick an I in front. But let's continue. All right, so now we've got this, and now we got to ask, what do we do with the square root of 15? Well, just like the square root of 20, we can't do it, so we should ask ourselves, can we do part of it? Well, what's the only way, and I'm going to move all this over some, what is the only way to break down 15 as a multiplication problem? The only way to break down 15 as a multiplication problem is 3 times 5. But the purpose of breaking down a square root like this is to find a piece that you can answer. Well, do you know the square root of 3? No, it's irrational. It's a decimal that goes forever and never repeats. Do you know the square root of 5? I don't know that either. So now instead of having one square root I can't answer, I have 2 square roots I can't answer. I just made the problem worse. And this happens sometimes with square roots. You might try to break it down in an effort to make it simpler, but you'll find out that it's not. So you just don't mess with it. So what does that mean that we do? Well, when you simplify a square root, you do as much as possible without having to get out decimals that go forever. And we've reached that juncture already, which means that this is actually our answer. Could we put the I at the end? Yeah, but I don't like putting I's at the end of square roots. All right, so when you simplify a single square root with a negative, pull the negative out inside of its own square root, instantly turn it into an I, and then deal with the rest of it. Now, there are some more types of problems that you're going to run across in your homework that involve simplifying. Most of them involve multiplication and dividing. There's a couple of exceptions. For example, let's say I ask you to simplify the square root of -3 times the square root of -15. And now we've got 2 square roots of negatives multiplied by each other. Now, there's a couple of schools of thought here. Number one is to deal with each of these individually. Let me fiddle with this, let me fiddle with this, and see what happens next. Number two is to instantly smush them into one gigantic square root. In other words, to start by just saying square root of -3 times -15. Don't. You might have caught it earlier because I said it really subtly. But back here, when I went from this line to this line, I said you can split up a square root of a multiplication problem. You can split up a square root of a product into a product of square roots as long as at least one of the numbers is positive. A lot of people don't catch that last part. In other words, and I'm going to write it here, this move works. This only works. Let me take the font size down a notch. This only works if at least one of the numbers is positive. And there are mathematicians, professional math people that overlook this because they're not paying attention. They just assume, oh, I can split up the square root across the multiplication. You can unless all the numbers are negative. But in this case, at least one of them is positive, so we're okay. If we go back over here, oh, by the way, that's a bidirectional thing, meaning I can go in either direction. But that only works if at least one of the numbers is positive. We're not going to get into the reason why it doesn't work if they're both negative, but because these are both negative, and this is worth typing here, because both, and I'm gonna do something. I want to change this color to darker, and I want to take that font size back up. Because both radicands, I'm bringing a new word in here, radicand, that's the part under a square root, are negative. We cannot combine into a single square root. So what do we do instead? Instead, simplify each individual radical first. I'm going to widen this. I don't want it to take up 3 lines. I don't want it to take up 2 lines if I can help it. There we go. All right, so because both radicands are negative, we cannot combine into a single square root. Instead, not a square root, Instead, we have to deal with each one separately, but that's what we just got finished practicing. So we should know how to deal with these now. I'm not going to be switching back and forth between red and black, but I am going to manually break off the -1 from each square root. And so the problem becomes the square root of -1 times the square root of 3 times the square root of -1 times the square root of 15. Now I know what to do with the square root of -1s. They become i's. I times the square root of 3, I times the square root of 15. Okay. Multiplication is associative, which means that, and commutative, which means if we have a long multiplication problem, we can shuffle the numbers around, put them in any order we want. I'm going to put the two i's together. In other words, I'm going to multiply the I times the I to make I squared. And notice that my two square roots, the square root of 3 and the square root of 15, now I can combine them because they're not both negative. They're both positive, in fact. So I can multiply those together. 3 times 15 is 45. But we're not done yet. This is going to be continued on the next page. So let me go to the next page and write I squared times the square root of 45. Why is this not done? Well, it's not done for two reasons. Number one, I squared, you're obligated to change it to -1. So I already know that the I squared has to become a -1. But number two, the square root that we just made might be able to be simplified. In fact, we'll just take it to the side and see if we can do that. Can you think of a multiplication problem equal to 45, where one of the numbers I can square root? How about 9 times 5? There is a way to make this split without making any decisions. You just follow a process and it tells you how to split it. I'm not going to embed it in this video because it's already long enough, but if you want to know the technique for knowing how to simplify a square root completely without just guessing, let me know and I'll make up a quick video. Square root of 9 is 3, square root of 5 I don't know. This goes back into my answer. So we have -1 times 3 times the square root of 5. I know the answer to -1 times 3, and this problem is over. I don't know why green suddenly became the color of the box to put around my final answers. So that one's a little bit trickier because you've got two negatives to deal with in square roots separately. And then when you put it all together, you get a bigger mess to clean up. All right, let's take a look at, I think there's a couple more I want to show you, 2 or 3. I'll try to go a little bit faster on these because I know this video is already going a little bit longer than I wanted. For example, let's take one that looks harder than it is. Simplify the square root of -54 over the square root of -6. Now, it's a fraction, oh no. And if you're wondering, can we combine it into one square root? The answer is the same answer as for multiplying. If they're both negative, no. Otherwise, yes. But these are both negative, so the answer to that is no, I can't. So what do? Same thing we did before. We simplify each one separately first. And let's go ahead and get right into it. I can pull the -1 off of the first square root, give it its own square root on the top, negative square root of 1 times the square root of 54. And the same thing on the bottom, I can break the negative off of the 6 and write the square root of -1 times the square root of 6. I know what happens to both square root of -1s. They both become i's. So I have I times the square root of 54 over I times the square root of 6. Now, in this case, we got an I multiplied on top and an I multiplied on bottom. And you might be wondering, can I cancel them? And the answer is yes. In a fraction, you can cancel parts of multiplication problems that match. These match, they're gone. And although I still have a fraction with a square root on top and a square root on the bottom, at least there's no negatives and no i's. But can I put them together? And the answer is yes, you can. Problem's not over. But in this one, and we'll put this in orange text to match, you can combine these since both are positive. I'll fix the text box here in a second. Actually, I'm going to have to take the font size down. You can combine these since both are positive. So we are going to go to the next line and continue by combining it into a single fraction. 54 divided by 6 is exactly 9, but it still lives under a square root. Square root of 9 is 3, and now it's over because there's absolutely nothing left to do. So the fractions and the multiplication problems, you just have to proceed with caution. Just remember that you can combine them into one square root as long as they're not both negative. Otherwise, if they're both negative, you have to deal with them individually, see the fallout, and then proceed. All right, a couple more small things I want to show you. One of them is going to use a result that we already had in a previous example so that we don't have to rehash another type of problem. Although in your homework, you might have to rehash it. I'll explain what I mean in just a second. But let's say I give you another simplify the expression, very generic instructions for here's a mess, clean it up. Let's say I give you something like 24 plus the square root of negative 20 over, we'll say over 4. If you're like, what are you doing to me? I'll tell you right now that this type of expression is one that will show up as a result of solving a type of equation down the road. So we're going to encounter this later, so we need to know how to clean it up. Now, there's two perspectives. There's two things here that you need to worry about. Number one is the square root of negative 20, but we've dealt with these square roots before, and we've dealt specifically with this one. It was back here. So we already know how the square root of negative 20 is going to conclude. We're going to use that to our advantage in a minute. The other thing is in this fraction, there are numbers that look like they can be reduced, 24 and 4, 20 and 4. So is there any reducing that we can do? And the answer is yes, but carefully and at the end. So what's the best way to attack this? Well, the best way to attack this, one second, folks. First, simplify the square root. And that was a previous example, so we're not going to redo that again. But that would be the first thing we do. We simplify the square root. And that square root ended up being 2i times the square root of 5. So we will put all that in yellow to say that this became that. And again, that was from a previous example. Now, once you've done that and simplified the square root, the next issue is, can I simplify the fraction? And the answer is yes, but you have to do it cautiously. There's a couple of ways to do it, but here's what I found to be the easiest way that always works. Split into 2 fractions, semicolon, reduce each. It's tricky to reduce a fraction that has a plus or minus inside of it. It's not impossible, but it's a little bit treacherous. I do want to try to grab all of these things and move them over to the left so that I have room on the right. Okay. All right, so what do I mean by split into 2 fractions? Well, it's kind of doing the rule for adding fractions in reverse. The rule for adding fractions is get a common denominator and combine the numerators. It looks like that's already happened, so I'm going to split it back apart. 24 over 4 plus 2 square root of 5 over 4. Oh no, I forgot my I. Well, I didn't. But now that it lives in its own fraction, I'm just going to stick it out to the right. Because remember, normally we put the I after something, and in this case, we did it there. And now within each fraction, we can consider reducing. 24 over 4 is just 25 divided by 4. That's just 6. Not a whole lot to worry about there. But here's the plus. What about the other fraction? Well, in the other fraction, we have 2 square root of 5 over 4. Now, you may be tempted to reduce the 2 and the 4, but then you may question yourself, is that something I'm allowed to do here? In a fraction, you're only allowed to reduce parts of multiplication problems. The 2 on part is part of a multiplication problem, 2 times the square root of 5. So now I can just look at the 2 itself and then try to reduce that. And if I reduce it, I can reduce the 2 by 2 to get 1 and the 4 by 2 to get 2. What does that leave me with? besides a mess, it leaves me with, one second, folks, I'm trying to do something real quick. So what does that leave me with? It leaves me with an I with a fraction in front with a 2 on the bottom, but on the top, I'm left with a 1, but there was also a square root of 5. Well, 1 times the square root of 5 is the square root of 5. And that would be our final answer. It's really not that difficult to get there as long as you know that there are 2 moves to do in a particular order. Simplify the square root, that's a task in its own right. And for the fraction, split and reduce. Actually, this covers everything I wanted to cover. So there's a lot of things in this section. Take them slowly. Every one of them is in here because it's also inside of your homework. If you got any questions, you know how to get a hold of me.